In this question, a vertical cone has a base diameter that equals its height, and water is flowing into the cone at 2 meters cubed per second. And part A, if the height h of the cone is 6 meters, find its volume. So this is just figuring out the volume of the actual cone using the volume of a cone formula. So that is V equals pi r squared h on 3. And drawing a cone, there's my cone, and it also tells you the base diameter, which is this top here. Even though the cone's upside down, that would still be considered the base. And the base diameter, the diameter of that base is equal to its height. So, and it also tells you the height is h. So marking those in, height h, and if the diameter is h, then the radius is going to be half of that. So here the radius equals h on 2. And then subbing r equals h on 2 into here, and also the value of h being 6, the volume would then equal pi r is h on 2, so squaring that, and then times by h on 3. And I'm going to tidy that up before I sub in h is 6. So squaring both of these, you get h squared on 4, squaring both numbers in the bracket, or both things in the bracket, times h. And because this is really pi over 3, that 3 can go here on the bottom with the 4 like that. And so that's pi h cubed on 12. And then subbing in h equals 6, that becomes pi times 6 cubed on 12. And that equals 18 pi, which is equal to 54.5486. And because this is meters, height measured in meters, that's going to be meters cubed. So that's the volume of that cone. Part B, find the rate at which the height of the water is increasing in terms of h. So the rate at which the height of the water is increasing, so that's going to be the change in height with respect to the change in time, or dh dt. And being a related rates question, you're going to have to connect this with the rate that you're given here, which is a volume unit per time. So that's going to be dv dt. So dv dt is going to be in this formula. And so this is just going to become dh dv, and then dv dt here. So in the related rates formula, you're always going to be given one of the rates, and you've just got to figure out the other one, the letters, or the actual rate itself, the expression for the rate, from what you're trying to find. And these two are always the same. So it's not the hardest part of the problem, but you've got to know how to set this up correctly. So this one you know is equal to 2 meters cubed per second, but this one here, what you need to do first is find dv dh from the volume here, pi h cubed on 12. So dv dh is going to be, so bringing down the power, times by pi h, decrease the power by 1, becomes 2 on 12. 3 into 12 goes 4, and you end up with pi h squared on 4. So therefore dh dv is equal to, and just turn that upside down, so 4 on pi h squared, and then sub that into here. So that becomes 4 on pi h squared multiplied by that 2 meters cubed per second, so meters cubed per second. And the units for this one here, looking at dVdh, this is the change in volume, which is meters cubed, per the change in height, which is meters. So meters cubed divided by meters is meters squared. So the volume is changing with respect to the height at the rate of a meter squared unit. So that means this would be meters squared here, which means when you turn it upside down, the meters squared are going to be on the bottom here. And then that would cancel into the meters cubed to give you meters per second. So 4 on pi h squared meters per second, which is the right unit for a change in height with respect to the change in time. So you don't normally have to do it that way. That's more the kind of thing you would do in physics, but that's a way of doing it. But really the easiest way of getting the correct units at the end is just look at what you've got here and make sure you put the right units that you've been given in the problem. So that's what dH/dt is equal to, and it's in terms of h, and so that's the answer to the question. And another point I'd like to make with this is that because this is h squared on the bottom, you've got 4 divided by a number on the bottom that's going to be getting bigger as h increases. So as h goes from, say, 1 meter to 6 meters, that becomes 1 squared, and then you sub 6 in and you'd get 6 squared. So the value of this is increasing, or actually the value of the bottom is increasing as the height increases, and 4 divided by that means that that whole number there is going to be decreasing or getting smaller as the cone fills with water, as the height of the water is increasing. So, which you'd expect with the cone, because it's narrower at the bottom, it's going to rise faster at the bottom than it will at the top, because there's more water to fill in that space. Like each layer of water, as each unit of water goes in, it's got to fill a bigger space the higher up you go. So that's another way of looking at that expression there and adding a bit more understanding to what it actually means in terms of the actual problem. So that's about it for this question.